Math 7, Unit 2, Solving. Lesson 1, Part 1. Terms and like terms. On a few trips to the grocery store, you buy 7 bananas, 5 apples, 6 oranges, 4 apples, 2 bananas, 6 apples, 11 oranges, 5 pounds grapes, 6 oranges, and 2 pounds grapes. I'd like to rewrite this sentence so that it has the same information, but it's not as long. So I'm going to start with on. So I'm going on a few trips to the grocery store still. On a few trips to the grocery store, you buy, okay, let's combine some things together here. 7 bananas and 2 bananas is 9 bananas. So we can just say you bought 9 bananas. We can also put together the 5 apples and the 6 apples. That's 11 apples. And 4 more apples make 15 apples. So you bought 15 apples. Let's see, you've got oranges. There are 6 oranges and 11 oranges make 17 oranges. Plus 6 more oranges is 23 oranges. Must really like oranges. And all that's left is the grapes. It looks like 5 pounds of grapes and 2 pounds of grapes make 7 pounds of grapes. So we can take the fruit that is in the same category and add them together to make the sentence more brief, not as long. Okay, here's another example. Mr. Gubler's math class has 17 boys and 14 girls. Mr. Goodrich has 15 boys and 17 girls in his math class. Miss Foley has 19 girls and 12 boys in her math class. Mr. Burgess has 23 girls and 9 boys in his math class. How many boys and how many girls are in the 4 math classes? Okay, so for boys, I can just take the boys from every class and just add them together. That's 17, 15, 12, and 9. That would be, let's see, 12, 14, 23. That would be 53 boys. So there are 53 boys. And the girls we have 14, 17, 19, and 23. So 14, 17, 19, and 23. Let's see, 4 and 7 is 11, 20, 23. 3, 5, 7, 73. Did I add that right? That looks right. Did I copy it over right? Yeah, everything's good. And 73 girls. Okay. This is similar to this expression in a way. It actually has different meaning. Up with the thing talking about boys and girls, we're just adding together things in different categories. Here it does have slightly different meaning, but it helps you, this helps you know how to do it. What you do is you take all the ones that are able to be grouped together. We're going to later call them like terms, and they can be added together to get 53b. We can take all the g's and add them together, and there's 73 total. And you're essentially doing the same type of thing. It does have different meaning, but that's the basics of it. So right here, 7 plus 6y plus 3y. 6y and 3y are in the same group. So we could actually combine them to make 9y. So we're just kind of doing the same thing, but more abstractly now. Right here, 13 and negative 15 are kind of in the same group. They'd make negative 2. 7u and negative 10u can make negative 3u. And negative 5g we're just going to have to bring down. So everything in the same grouping can be put together. Now those things are called terms. Now terms consist of just variables, numbers, or both. And they're separated by plus and minus signs. So right here I have 3 terms. Right here I have 5 terms. Now remember that terms, they actually do include the sign in front of them. So the terms here are 13, 7u, negative 5g, negative 15, and negative 10u. Okay, the vocabulary. So this is in the notes. A variable is a letter or other symbol used to represent an unknown quantity. Generally, we use letters of the alphabet. A term. It's a number variable or a product of numbers and variables. Terms are separated by plus and minus signs. And there's some examples there. Like term. Terms that have the same variable parts. So for example here, 3, 6, and 8 have no variables in them. They are constants. All constants are like terms with other constants. 4x and 9x, yeah. 3xy and negative 5yx, those both have x and y as the variable part. Keep in mind though that 3x and 4x squared are not like terms because they don't have the same variable parts. This has an x, this has an x squared. X squared is x times x. X is not the same thing as x times x. Coefficient is the number factor of a term. For example, in 3, it's 3. 15.4 is the coefficient in 15.4x squared. 3/4 is the coefficient of that term. If there is no number written in front of the term, the coefficient is 1 because it's just not written there. You don't have to write times 1 because it doesn't do anything. Okay, distributive property of multiplication over addition. When a factor is multiplied by a sum, the result will be the same if each term in the sum is multiplied by the factor then added. And we'll go over more detail of that later on in the video, or next video. So in your notes, the first thing is to identify terms and like terms in each expression. Example 201 is already done. The terms there are 4 of them. They are 4xy, 9x, 3x, and negative 2. The like terms are just the 3x and the 9x. Example 202, it has terms, 3 of them. They are negative 3.5g, 2g squared, and negative 3g squared. The like terms are the ones that have the same variable parts, which would only include the g squareds, 2g squared and negative 3g squared. Remembering that the negative 3.5g only has a g, not a g squared. Okay, next example, the terms are, there's 3 of them, 5x, 7x, and negative 10x. The like terms include 5x, 7x, and negative 10x. All 3 of them together are like terms. Okay, identify the terms and like terms here. By the way, you'll be doing this on number 1 on your assignment. The terms are y, 10, and negative 3/2 y. Remember, the negative is part of the term that comes after it. The like terms include y and negative 3/2 y. Next example, there are 4 terms. 2r squared, 7r, negative r, and negative 9. The like terms are only 2r squared and opposite r squared. Those are the only ones that are actually like terms. The other ones aren't. Okay, the last one here has 5 terms. They are 7, 4p, negative 5p, and 2q. 4p and p are like terms. So like, we've got 4p, whoops, not b, pardon me, 4p and p. There's also 7 and 5 that are like terms. So there's 2 sets of like terms on that one. And go to the next.